All right, we are back for part two of our robotic safety lecture here. Let's just talk real quick about some of the general safety guidelines that you need to be paying attention to. So we use these guidelines to kind of start to put our safety program into place and make decisions on how and what we should actually be doing in regard to the robot that we're putting on the shop floor. So we got to consider the size and shape of the robot's work envelope. We got to consider the methods of motion control that are being used. So those kind of can impact. If everything is electronically controlled, we're going to kind of do that a little bit differently as opposed to something that has got hydraulics and pneumatics. So we have to kind of be aware of all of those. What are the limits of the payload? Now, if you're not sure what the payload is, that's the amount of weight that the armature can kind of lift and carry and move. So obviously, the heavier the payload, the more potential for damage to people, property, and product. So we got to kind of think about that as well. So what is the range of operating speeds? Now, here at Richland in our robotics lab, our robots are teaching robots, they're education robots. So they're slowed down quite a bit in comparison to what most industrial robots are. So one thing that I want to point out to you, if you are not at all familiar with robots and have never really had anything to do with them before, don't get used to the speed that our robots use and that our robots are moving at. It is very, very slow in comparison to what you're going to see out there on a shop floor with industrial robots. So just bear and keep that in mind. Always kind of look at and find out what the operating speeds are of those robots. And then, of course, there's any other features that might be provided for the manufacturer there too, either with end of arm tooling, different sensing devices, different types of hydraulics and pneumatics that might be kind of put onto a robot or might be considered an upgrade to that robot over a standard robot that you might buy. So we got to consider all of those when we're developing our safety guidelines here for our robot installed on a plant floor. All right. So let's talk first here about the actual workstation. So when we're talking about the workstation, we're talking about everything that's encompassing the actual work envelope of the robot and where the actual workers would need to be able to work to safely operate in, on, and around that robot for whatever task it's doing. So we have to make sure that the worker can get around the robot, access the robot, program the robot, and that they can do that safely. And at the same time, also protect other people that might be in the area and other workers that have no idea what the robot is, that have no responsibility whatsoever in regard to the robot. But still, you're going to have other employees that are going to be walking and moving by that robot. So we got to be aware of all of that for them. Be aware of fixed objects in the area. So anytime, if we've got posts, pipes, drains, anything that might become a pinch point that the robot could trap somebody between, or even get the armature of the robot trapped itself. So we got to pay attention to where those are when we decide where to place the robot on the shop floor. We can use paint or colored tape to outline the perimeter of the robot's work area. So that's a good start. I would say it doesn't go far enough. So we need to kind of do other things that would be making people aware of potential hazards and safety issues when they kind of walk into that area around that robot. So, and in order to do that, besides just having paint or colored tape on the floor, we can also use safety barriers around the robot. Safety barriers are the best bet. They basically keep unauthorized people out, and limits the access that employees would have to the robot. So once those safety barriers are put in place, of course, we've got to have control panels that are outside of that work envelope and put interlocks in place too that also prevents unauthorized access to that robot too. So our procedures to ensure worker safety. Now, most of you probably are not going to be working to develop these procedures or put these procedures in place. So unless you're working for a real small company, um, and then you've got a lot of stuff to do. If you are with a very small company that doesn't have a safety manager on staff, I suggest that you get some outside help and contractors. There are people out there that specialize and are the experts in this. So for smaller companies, um, where you wear multiple different hats, it never hurts to call in an expert and get some extra help just to make sure that things are safely done. So, part of that procedure is to implement a two-step procedure to resume operation after a shutdown. So, anytime the robot has to be shut down, have protocols where it requires two steps in order to get that robot up and going, just as an extra safe, what we've referred to as a fail-safe. So document and design those procedures. So everything should be documented, of course. So put the actual design on paper, do on your shop floor layout. So in terms of the plant design, write out physical work orders or standard operating procedures that need to be followed, and these need to be done for every type of worker that might be coming into contact with that robot as you go. So make the purchasing department, operating and maintenance personnel, make sure that they are all aware of those procedures and following them as well. And of course, that also brings us to the last point: operating personnel, programmers, maintenance workers, even cleaning crews should be given extensive training on what they need to know, what they need to do, and how they can protect themselves while they're working around that robot if they have a need to. Make sure that you also offer those periodic refreshers as well, because human nature, I mean, if we do a training once, it doesn't mean that we're going to remember everything that is there, 6 months later, a year later on down the road. Put in and install safety barriers and sensors. So this is also very important. So the textbook talks about how fences should be at least 6 feet above the ground. So there are all sorts of different types of safety fences that you can install, whether they're chain link fence, acrylic panels, or light sensors type of what we have a light barrier type fence, or what's referred to as a light curtain. So use those to prevent and act as a barrier to entry. It's also important so that basically as soon as somebody steps into that work envelope, those sensors go into effect, and they shut everything down so that there can be no movement of the robot while it's in there. We talk about pressure sensitive mats. Again, so an operator or some other personnel that would be stopping and stepping on that mat, their weight would also sensor and trigger a shutdown on that robot as well. Overload protection here is referring more to the actual protection of the robot and the end of arm tooling. So it is a way to kind of protect that part of the robot. So it's a feedback system where it sends some type of a signal is sent to the computer system before you can actually damage the end of arm tooling or the end effector. So there are breakaway devices that are used. So you do want to kind of know and understand what some of these are. We can use mechanical fuses. They're pretty cheap and inexpensive, easy to replace. Those are pins or tubes that break or buckle under extreme stress. We can use what's referred to as detents. That's 2 or more elements that are held in position with a spring-loaded mechanism. So, or we can use preloaded springs. Actually, a lot of robots have these preloaded springs in there where they cause the end effector to break away from the work area if excessive stress is applied to it. And generally, once you kind of move it back, the end effector will move back into place based on that spring. So those are some overload protection devices that can be installed and put in place on these robots as well. All right, so that kind of wraps up this safety lecture in the 2 parts. Again, the one thing that I want to mention here is I am not an expert on this. I don't really consider myself an expert. I'm kind of presenting the textbook information for you. Make sure that you do, if you are In a larger company, certainly the EHS department should be in contact, or some procedures should already be in place if you've already got existing robots. But again, it is your duty as a employee and a worker to be aware of these safety protocols. Make sure that you're following them. Make sure that you are going to, when you're working on them, that you're going to be able to leave at the end of the day knowing that you did a job well done and that you worked safely and nobody was hurt. I don't know of a single plant manager, and I would hate to work for any type of plant manager. I'm certain that none of them want to go and contact your family to explain that there was an accident where you got hurt at the end of the day. So make sure to be safe, practice these safety techniques, and work the way you're capable of working, being very aware of all the safety hazards that surround robots when you're working around them.